Good evening, everybody. It's Tuesday, the 19th of March 2024. Welcome to the Open University. We're not in the Open STEM lab anymore. We're in this wonderful room with a green screen. That isn't the real moon behind us, but we'll be talking moons. This is an event for S283, that's the Planetary Science and the Search for Life Level 2 course, which I chair, and also for learners on the Open University Future Learn Moons MOOC, and we've opened the invitation wider to anybody in the OU Planetary Science community who wants to join in. With me is Simeon Barber, who's been a colleague here for a lot of years now, who builds instruments to fly to the moon. More about that very soon. Before we start though, we've got news to report to you, and we'll find out what Sim does, but we're also here to answer your questions. We've had very few questions asked in advance this time, but those of you watching live, please use the chat to ask us questions, and we will attempt to answer those as best we can at a few seconds notice. We've also got widgets there. One's a map asking you where you're from. The other three, I wonder if you can answer, because we're asking you how many nations have put astronauts onto the moon. We're asking you how many nations have soft landed an uncrewed lander on the moon, and how many nations have brought samples back from the moon. We'll have a look at those widgets at the end, and we will reveal the answers and see how many of you got that right. So, Sim.
Hi.
We used to play football together. I think you were in a better team than me.
Yeah, nice to be in the team.
And you have got an instrument here which was built to fly to the moon. And you told me just now, you reminded me just now, that you came as a PhD student to build the predecessor of this, which actually went to a comet. But maybe we'll come to that. But this flew on there's been 3 attempted landings on the moon.
That's right.
The first one this year, called Peregrine.
Yes, yeah.
Didn't make it.
Didn't make
with this on board. But, let's talk about what this instrument is, first of all, before we find out what happened to the mission.
Yeah, so this is an ITrap Mass spectrometer.
Yeah.
It's a weighing machine for atoms and molecules. So we can use this to sniff what the atmosphere on a planetary body or a moon is made of, and identify its chemical composition, its isotopic composition, and also quantify it. So it's a really versatile device. Usually this kind of instrument in the lab, which we use from a day-to-day basis, would be the size of a fridge, something like that.
Yeah.
But for space instruments, we miniaturize them, and we end up with something like this. Okay,
so this sniffs as you descend to the moon, and it sucks in the very few atoms or molecules which are there. Where do they go in, and how do they get analysed?
So what happens is basically it's a metallic structure with electrodes and spacers which insulate. So it allows us. It's hollow. So in the middle there's a cavity. And by putting electrical currents onto it, we can create what's called a trapping electric field. So we've got this kind of dynamic electric field. And what we do is, at this end, we've got a filament. So it's like an old-fashioned incandescent light bulb.
Right.
Heat that up to red hot, and it emits electrons. We shoot those electrons into the middle of this cavity. And those electrons interact with the lunar exosphere, or atmosphere. And it ionizes them, creates them into positively charged ions. And once they've got a positive charge, we can manipulate and control the orbit of those ions. So we keep them in this ion trap for ages, like 10 milliseconds, which in the lifetime of an ion is eternity. Yeah. And then we eject them into a detector, which counts them. But the clever thing is that when we eject them, we do that in order of increasing mass. So we eject the light ones first, the medium ones, the heavy ones. And because each particular ion has got a characteristic mass, it allows us to identify what the molecules are, and then the detector counts them as well. So we work out what the moon's atmosphere is made of, and how thick it is or thin.
How do you sort them out by mass? Is it just the light ones move faster?
Essentially, yeah. So you basically, you've got these ions almost like dancing to the tune you play according to the electrical signals you play. You subject them to. So you just tease them out of the trap one by one, and you get beautiful peaks in a mass spectrum.
But I don't see how you get them in there in the first place.
So we've got tiny little gaps. So in between each electrode, You get there's this channel
I can
here.
see from this angle.
So there's
right?
there's just enough space there. So molecules are flying around, bouncing around everywhere. Eventually, they find their way in there, and they're in equilibrium basically with the lunar exosphere. But we need to have this kind of fairly enclosed structure to create this trap.
All right. So you're not sucking them in; it's just passively sampling what's there.
Passively sniffing the atmosphere as it changes through the lunar day.
And on the moon, this would be a very, very diffuse atmosphere.
Oh yeah, so yeah, a millionth of the atmosphere that we have on Earth.
Okay, but sadly, it didn't make it this time.
Not this time, no. So this was on the US's first commercial spacecraft launch. So this company called Astrobotic won a contract to build this spacecraft. First time they built a spacecraft. It was launched on a new rocket using a new rocket engine. Lots of firsts, lots of new things. So it's always high risk space, and certainly when you try and get to the moon first time, it's high risk. But we knew that, and one of the reasons for doing this was to demonstrate that this technology, which we'll be using again in future, can survive a rocket launch and can operate in space. So even though the mission went off course a few hours, in fact, after launch, which meant it wouldn't actually reach the moon, we were still able to turn the instrument on and get really useful scientific and engineering data from it and prove that we have a working mass spectrometer that's now space qualified, basically.
Which is very important to do. And did it sniff the leaky fuel?
Yeah, so what happened was that the spacecraft ruptured a fuel tank on the way to the moon, which is really unfortunate. But it looks like this device, which as well as being there to do science and measure the moon, is there to kind of monitor how a spacecraft interacts with the moon. So it does so happen that we managed to detect what molecules are leaking out the spacecraft fuel tanks. And so I'm hoping we can get really good data to the engineers to try and diagnose the problem.
Yeah. So this is going to fly again, isn't it?
Yes, it will, on a Japanese mission called Lunar Polar Explorer. So as the name suggests, it's going to the south pole of the moon in maybe 3 or 4 years' time. It'll be on a rover this time, and it'll be driven around the surface of the moon near the south pole, where we expect it to be very cold. We may well find ices, and we may have molecules subliming through the atmosphere. So we'll be trying to monitor how that atmosphere changes throughout the lunar day as it goes from hot at daytime to cold at night.
Lovely little instrument, and its heritage goes back to the one you helped build, or you built it solo, I don't know, that flew to the comet on Rosetta. Yeah,
exactly. So we started building this in the 1990s, that is. But that's in space it's really important to build on as you said, heritage.
Yeah.
So we try and incrementally develop that. But this is a beautiful device for the moon because it works really well in that very thin atmosphere.
Well, I wish it success next time, but there have been lunar landings this year. There's one on the screen behind us. This is Slim, the Japanese. That was the next attempt this year to land on the moon.
That's right, yes. So the very the very next day after our mission splashed down on Earth, the Japanese landed on the moon. Again, things didn't go 100% smoothly.
No, you can see the rocket nozzles pointing up into the sky on that view.
Yeah.
I at first thought they were meant to end up on the ground. In fact, it was meant to be on its long side, wasn't it? It came down with its retro rockets and was meant to land on its side.
That's right, yeah.
Actually tipped over and nosedived. I was watching this live on the web stream.
Yeah, me too. Yeah,
and we've got some of the graphics that were captured from the telecast. So we're watching data like this as it came down, and you can see the spacecraft in the correct orientation and the readouts of the speed and the height and so on. Let's just advance it. It kept going down towards the surface. So if we get the next picture, there it is, sort of on the ground or slightly underground, but they've exaggerated the size of the spacecraft. But the next instant, it was shown in the wrong orientation and underground.
And we didn't really know what to make.
We didn't know.
Did we?
The version I saw had some Japanese commentators in the foreground. They are looking a bit nonplussed, and you can see the spacecraft actually upside down. And I didn't know, you probably didn't, whether that was a true representation of its orientation, but it was. That's exactly how it ended up. Almost exactly on its nose like that.
Yeah.
But this is a view from the little hopper craft that they ejected just before touchdown, which hopped around on the surface and took this picture of the mothership, which is a lovely picture to see.
It's a fantastic image, isn't it? And it shows the value of getting an image back from the lunar surface, because there's so much information in that picture.
Yeah, there were meant to be lots of pictures from Peregrine itself, but not Slim itself, but the big lander. But because of the way it landed, the solar panels were in the shade and they had very little power. But it turned on eventually when the sun crept around the lunar sky, because the lunar day is about 28, 29 of our days. So it was almost a fortnight later when the sun crept round and hit the solar panels, it was able to take pictures. So here's a picture it took just before sunset. The sun is behind the view here, looking at those hills in the background. And we thought that's the last we'd hear of it, because there's a 2-week-long lunar night coming up. And of course, once it got dark, no solar power, very cold, it was good night spacecraft.
Well, that's what we all thought, wasn't it? Yeah, these spacecraft are not designed to survive lunar night.
They're not, but when the sun came round again, there we go. I don't know if it survived a second lunar night since then. There must have been 2 lunar nights now, but certainly survived 1 lunar night, which was great. And they did some science, didn't they?
Yeah, they had cameras on there that were multispectral cameras, so looking in different wavebands or wavelengths. And that allows them to kind of distinguish different rock types on the surface of the moon. So very much a technology demonstrator, basically the first really highly precise precision landing by a robotic spacecraft. But also, when you go in there to do engineering, you're going to do science as well. So yeah, they got some nice images back as well.
Yeah, so well done the Japanese Space Agency, JAXA. And then not so long after, another commercial lunar payload system launched by NASA and a different company this time.
That's right, yeah, so Intuitive Machines this time.
And how did that fare?
I'm going to sound like a broken record here, aren't I? So this was an interesting one. So landing on the moon's difficult, okay? You arrive at the moon on a spacecraft at something like 2 kilometers a second, which is pretty speedy. To land, you need to be going something like, less than 2 meters per second. So you've got a massive braking maneuver, and you need to know where you are relative to the surface. So things were going okay until they realized that basically they had a laser altimeter, which was meant to work out how high above the surface of the moon they were. That was not going to work during descent. So they had to re-engineer the landing process, and they ended up landing just using cameras essentially. So they had cameras looking at the surface, and then the computer trying to work out with a kind of triangulation process how high they were from the surface of the moon. They did quite well, but they came down slightly too fast vertically, but they had some sideways momentum, which meant that when the landing legs hit the ground, they weren't designed to take the sideways force, and they had they broke their leg on landing basically.
It's another spacecraft that tipped up, really.
It really strange, but it ended up in a remarkably similar, slightly off landing
but
position.
But it survived. We have a couple of pictures it took of itself. There's one view from the surface. It looks a bit cockeyed, but you can't really see what's wrong on that, can you? But there is another shot.
And that's an amazing image.
There's some broken landing gear there.
So these legs are very spindly, and because the moon's gravity is a sixth of that on Earth, but they're designed to absorb force in a vertical direction. And if you have the spacecraft moving sideways, then these legs kind of catch in the ground and then break. But you can also see on that image there that the rocket exhaust is blasting the surface of the moon away. So you've got these pebbles or rocks being pushed away, moved at kind of supersonic speeds. And so we kind of, it's a dynamic process and a brutal process landing on the moon. And, these spacecraft got 90% of the way there. And the key thing is they've got the data now to learn and do it properly next time.
And so this is more or less the instance of landing, but it did survive the landing and
again, these are resilient spacecraft. They're not, you can't claim they're 100% successful, but, the point's been proven. And the key thing is, like I say, with these images now that we're getting, you learn so much from that about what to do right next time.
So how often are there going to be NASA commercial attempts to land on the moon?
Well, the simple answer is frequently. So the whole idea here from NASA has been to try and stimulate a US commercial spaceflight capability to deliver NASA payloads to the surface of the moon, but also for companies to kind of build their own business case for doing commercial lunar missions. So if there are people out there who want to pay for scientific investigations on the moon, you know, note out to my funding agency, that kind of thing. You know, here is an alternative now. So these missions typically are cheaper than kind of big flagship science missions. That means they're allowed to have a higher risk profile. That's that kind of cost benefit. But there are certainly more missions later this year, and you know, I think they're going to start being fully successful soon.
Okay. But NASA are also planning to send people to the moon. This is via the Lunar Gateway.
That's right.
Which is a successor to the International Space Station. It'll be a station orbiting the moon.
That's right.
And it'll be occupied about 1 month every year. It won't be permanently staffed.
Yeah.
And from there, astronauts will descend to the surface.
Yeah.
And how much of that is going to be commercial and how much of it will be run by the government?
A lot of that will be commercial. So we know about SpaceX, providing these huge rockets to blast big payloads off the ground. So it is all about a partnership between space and agency. Of course, the big difference when you've got humans involved is that you need to have much more reliable missions than these robotic missions. Yeah. So I think the plans in place at the moment are to have humans, US landers with astronauts on the moon in 2026, 2027. I think that's challenging, if we're honest. And they've got to do this at the right pace to make sure it's safe, clearly.
Yeah, there's been an Artemis craft that's been sent round the moon with nobody aboard, apart from a toy Snoopy. That's the European Space Agency's contribution. Well, no, they provided the service module, didn't they? For
That's right, yeah.
So the next time it flies, there will be people on board.
That's right, yeah.
Just straight round the moon and back again.
That's right, yeah.
Which is, it's been delayed again. Is it 2026?
I think 25 or 26, yeah.
Yeah.
And then the one after that is then trying to land near the South Pole and then putting that gateway in place to have this kind of, transport between lunar surface and orbiting station.
And now the Chinese have announced in the past month or so, haven't they, that they plan to send people to the moon before 2030?
That's right, yeah. So the Chinese have had a really, really successful, I'd say, and really strategic program in a number of stages. They've been ticking off lunar orbiters, lunar landers done, lunar sample return, so we've got new samples on Earth, amazing. And yeah, they want to put astronauts on the surface of the moon by 2030 using 2 spacecraft, really interesting. So send a lunar lander, uncrewed, send a crewed spacecraft, rendezvous them at the moon, transfer the astronauts over, go down to the lunar surface in that lunar lander. So very different to how the US went with Apollo in one craft all the way to the moon and then brought some of it back. So there's different ways to do these things. Yeah.
There's another Chinese asset at the moon which you didn't mention, which is they have a relay satellite hovering over, it's not hovering, but it's orbiting over the far side of the moon in one of these very strange orbits. So it's keeping station on the lunar far side so they can communicate from the far side back to Earth, because this one always sees the Earth. It's far enough away from the moon, it can see past the moon to the Earth. And that's what they use to communicate with their far side lander. The Chinese are the only people to have landed on the far side of the moon. Remarkable achievement.
Yeah.
So,
and it shows that kind of, the strategy there and building an infrastructure. So the whole point about this new era of space exploration is it's better not to have all eggs in one basket and try and do everything in one go. You're trying to put a relay station there. You're trying to put an orbiting craft that you can use to kind of hop down to the surface and get back again. So if you have this infrastructure in space, there'll be Wi-Fi on the moon, GPS. So, that enables you to then just do missions because you don't have to take all that infrastructure with you.
There's GPS being talked about for Mars as well. I was talking to a colleague the other day. So things are moving on quite a lot.
Definitely.
Do you think NASA's going to get back with humans to the moon before the Chinese, or do you think it matters?
I don't think it matters in the bigger scheme of things. I think we also, it's human nature, isn't it, to try and see it as a race.
And the press will see it as a race.
Absolutely, absolutely. I get asked this question all the time, Who's going to be first to do this? Who's first to do that? We all win. You know, someone will get to the moon. The important thing now, though, it isn't about putting a flag there, being the first, because only one person can be the first. It's about making sure that when you do this, you're in a position to make the next step. And of course, you mentioned Mars there. The whole idea in this, international strategy is we use the moon as a springboard to go on to Mars and put humans on Mars next.
There are people on the FutureLearn Moons MOOC who are rather horrified at the thought of going to the moon, and that humanity is going to be raping it of its resources and despoiling the place. Right. What do you say to that?
I think it's really interesting, and I think those questions should be asked. So what we didn't say was that when I came to the university, I came to build mass spectrometers to do environmental monitoring on Earth in an Earth science department. I somehow got co-opted by one of your predecessors onto working on space missions. So, I believe in that. I think we should be respecting the moon, and we're trying to take giant strides, but we should step lightly as well. So what this instrument's really good at doing, it's not just doing the science at the moon and establishing what the moon's environment is like now, but it's also understanding what the effect of this exploration has so that we can monitor it. So, I'd like one of these to be on every single spacecraft to understand how that spacecraft might be interacting with and contaminating, being honest. But then if we understand that, we can limit the contamination that happens. It's going to happen, so I think we need to do it responsibly.
Yeah. Well, thank you, Sam. Very, very interesting stuff.
Cool. So, Dave, most viewers know that you're involved in ESA's mission to Mercury.
Yes, so, I am.
Yeah. What's going on there then?
Well, we're still in cruise. We get into orbit about Mercury late December 2025, which is 1 year and 8 months away, or something like that. We have another flyby of Mercury in September. It'll be our 4th flyby, but we don't get much science from the flybys because we have 2 spacecraft stacked together in cruise configuration. But we have a healthy Mercury mission, Bepi Colombo. It's a European Space Agency collaboration with JAXA, the Japanese Space Agency. Yeah. Very excited about it. I have 2 big grant proposals out there waiting to be funded now. So we've got a mission now. We need the money to do the science when we get there.
I know what that feels like.
Yeah, absolutely.
Okay. So apart from Bepi Colombo, what else has been going on in planetary science that's been there?
Well, last week was the Lunar and Planetary Science Conference in Houston. I didn't go, but I attended some of the sessions remotely, and one thing that caught my attention was a hitherto overlooked undiscovered volcano on Mars. We can see the pictures where it is. I missed the talk, but I've read the associated paper. This is in a place called Noctis Labyrinthus, which is, if we get the pictures up, okay, here's quite a wide view of Mars. There's a 250 kilometre scale bar on the bottom left, is there? Top left is the biggest volcano in the solar system, Olympus Mons. The cracks at the bottom right are Valles Marineris. There are 3 volcanoes in a diagonal line across the middle. Those are the fastest volcanoes. And Noctis Labyrinthus is in between the fastest volcanoes and Valles Marineris. This is just an image view. Let's turn it into colour-coded topography in the next slide. There we go.
Okay, so you start seeing the details emerging.
The tops of the volcanoes are in white, and the lowest terrain is in green, and you see Valles Marineris, the green cracks. Noctis Labyrinthus, well, we'll put a circle around it on the next image if we just move on. There it is. That's more or less the diameter of a supposed eroded away volcano. Okay. Let's zoom into it. It's not that obvious. Okay, there we go. We'll put the circle onto it as well. So there's an impact crater in kind of the sort of 5 o'clock position from it, but the base of the volcano would have been round about there, and you're meant to be able to see traces of a summit caldera in the middle, some of the volcano slopes. Those kind of mesas, plateaus in the middle are quite high. They're the highest region in the neighbourhood. Right. So it's not a continuation of a general bulge of fastness. It is a high point. So it's credible, but it's a deeply eroded volcano.
You sound intrigued, but still to be 100% convinced. Is that fair? Or?
That's a pretty accurate assessment, Sim, and I think probably most people who were at the meeting would say the same. It's certainly worth further investigation. People should be looking in more detail at those sort of high plateaus and see if you can see traces of lava flows on them, see if there's any mineralogical evidence. But it's a fascinating region. With, the Valles Marineris, the biggest canyon system on the planet, and this Noctis labyrinthius places, these randomly oriented fractures. Okay, they've been exaggerated by water runoff at some point, but it's a very interesting part of the planet. And the fact that there might have been an absolutely stonking big volcano there that's been eroded away and nobody noticed, it's kind of hiding in plain sight. If it's correct, it would be fascinating.
I think so.
I like volcanoes.
That's a good place to put a lander, isn't it?
That would be a very difficult place to put a lander, because on Mars you try to land with a parachute. So you want to go as deeply into the atmosphere as you can. The summit of this eroded volcano is still very high. You could land in the bottom of Valles Marineris where it's nice and deep. So most landers on Mars are below the zero height datum because you use the parachutes.
That's right. Yeah, we've got experience of Mars landers, haven't we? But
we
have a story for another day.
We're working on Beagle 2 as
Beagle
well.
2,
yeah. We put a lander on Mars, which it landed, but it just didn't open up and communicate.
There's a theme here, isn't there? It's just this final stage. So someone told me that to land on a planet is easy. It's just surviving the landing that's the difficult thing.
We do these things not because they're easy, but because they're difficult.
That's right.
There was other stuff at LPSC, which is going to be a bit of a disappointment to people on the Moon's MOOC and people who have recently read about Europa in book 2 of S283. There were 3 or 4 papers that had looked at the likely conditions of the floor of Europa's ocean. Europa's an icy moon. It's got about 100 kilometres worth of ice outside its rocky interior. Most of the ice is molten, so you've got a water ocean, a global water ocean. And anybody who's played moon trumps will have come upon Europa as probably the likeliest venue for life in the solar system. Big global ocean. And we were thinking hot vents on the ocean floor, hydrothermal vents, volcanic eruptions. So you've got some chemistry going on. People who've done modelling of the strength of the outer part of Europa's rocky interior have suggested there's no way faults today are going to propagate through it. Of a tidal flexing, which keeps the interior warm, isn't enough to cause fault movement, and faults will all be closed. And people have modelled the ascent of molten rock magma from the interior up to the surface, the ocean rock interface. So magma's not going to get to the surface. The floor of the ocean is going to be geologically dead place, so you won't have the rich chemistry that people have been hoping for. So
there's like a seal at the bottom of the ocean, keeping those two worlds
basically
apart.
So you don't get the impetus to power living processes. Now it's dependent on models, so they might be wrong, but I think the optimism that we're going to have life on the floors of these internal oceans has been damped somewhat. But there are plenty of other internal oceans. Almost everywhere you look in the solar system that's icy seems to have an ocean inside it. It's just that Europa seemed like the best possible ocean for life. And now maybe not.
Maybe not. Jury's still out.
The jury
more missions needed.
Jury is still out. Yeah. Well, there are more missions going because there's juice on its way already, and there's certainly the Europa clip of a NASA mission. We're going to have things in the Jupiter system. Well, we've got Juno currently orbiting in the Jupiter system, which is sent back some lovely close-ups of Io already, and I think it's going to have some Europa flybys coming up. So we continue to learn about these places. Yeah,
and I think also you shouldn't prejudge what you're going to find there. You know, you need to go and make those observations without too much of a prejudged idea of what you're going to find. So it's good that there's two sides of the debate.
Yeah, absolutely. Science advances by having ideas overthrown, new ideas coming up. That's how we roll. We've had some live questions. Okay, Sam Nisri is saying, was any data returned from India's Chandrayaan-3 landing on the moon? We didn't talk about that. The Indians landed last year sometime.
So I get confused with numbers, but Chandrayaan-3 was, was that last? What was that? I'm trying to say I get my numbers right.
The last the only successful Indian lander on the moon. Let's answer that question.
So, yes, that's right.
Whatever number Chandrayaan it was.
So again, these missions are kind of, I've got to be careful how to say this, the key success of these missions that are trying to land on the moon, because it's really difficult, are to have that safe landing. And that's where all the mass of the kind of spacecraft is allocated to, is to have this safe landing. So there are payloads on these landers, and yes, images are obtained in new places, so we get more imagery close up from the surface, and of course that has much more detail than from orbit. But really what they've demonstrated there is that ability to land, and it's kind of tick that off now, and now really go for the kind of scientific hole-in-one with the next mission.
And Helen Collicott is saying, will there be international partnerships with the Lunar Gateway project? Very much yes.
Yes, absolutely.
It's everybody who's involved in the International Space Station, except the Russians, who are now excluded for fairly obvious reasons, and more partners as well, but many nations participating in the Lunar Gateway project. Yeah,
so again, I think this is a characteristic of future lunar exploration, Helen. I think, thank you for highlighting that, what nations learned about previous space exploration is it's very expensive. You can't get away from that. And yes, we don't, blast all this money off and land it on the surface of the moon or put it in a space station. The money gets spent on Earth and pays for jobs and all that kind of stuff. But when you share these endeavours, it brings nations together, and you can also be much more strategic about how this has been done. So yes, the work is being shared around. That brings its own challenges. You've got to coordinate all these things, but it's actually really quite nice to be working with different partners on this, and very much an international effort. Yeah.
And also, the programme is intended to be more inclusive in the nature of the astronauts. But there are going to be women, there are going to be people of colour. There's an amputee, I think, involved in the astronaut cadre. So everybody will be able to feel they've got a representative in the game. Yeah, absolutely. Yeah. Andrew Forth is saying, did the successful unmanned, or we say uncrewed these days, moon landings in the 20th century do something different compared to recent attempts? Was the problem not solved back then? I'm not sure if Andrew means the problem of how to land or the problem of the science of the moon.
So, it's a fair question. I guess what you're saying there, Andrew, is why have we had so many moon landers fail in the last few weeks and months? I think that's a very fair question. You get different answers asking different people. So some people say, yeah, we've learned all this, we know how to land on the moon, Dave, it's easy. But you've got to remember that those previous moon landings, and we're talking about Apollo, generally speaking, they were human landers. They were mega budgets. They were huge. They were a significant fraction of the GDP of the USA. The robotic missions that are going to the moon now are way less than 1% of the budget of those missions. They're really, but they need to be, and this is that's okay. So there's two factors. One is the cost is much lower, and fixed price contracts, all that kind of stuff. But also the idea that to innovate, you can do things, you can take more risks, and more risks have been taken. We're trying to do things more cheaply. But also, it's true to say that the knowledge has been lost to a certain extent. So there was knowledge about how to land on the moon. The best way to look at it actually is in the statistics that most first attempts to land on the moon fail, and that's what we've seen. We've seen a lot of first attempts just recently, and I think, to be honest, they got pretty close. Some of these missions within 50 meters of landing successfully. So, actually, I think they've done pretty well. And it will become more commonplace to have fully successful landings quite soon, I think.
Yeah. I want you to read that question out for me to answer.
I'm trying to read it, but I've touched it, and now I don't know where it is. Which one are we on?
That's it. There you go.
A question from Sam. Okay, so question from Sam Nisri. Why is Enceladus talked about less than Europa in the context of possible life in subsurface oceans of our solar system? One for you, Dave.
Well, Sam, I'm not sure Enceladus is talked about less. I mean, the two prime candidates are Enceladus and Europa. Europa's bigger, so has potential to support a greater diversity and a greater amount of ice. But Enceladus, again, moon trumps, quite a small moon of Saturn. It's a lot smaller than Europa, but it has a global ocean. That's been proven because the surface rotates at a slightly different rate to the interior, and it has these plumes coming out from the ice that have been imaged by the Cassini mission when it was there. So that's samples of the ocean jetting out to space, which have been analysed by the onboard mass spectrometers. They weren't designed to do this, but it did a damn good job. And we know that in these ice plumes there are simple hydrocarbon molecules. There's also molecular hydrogen and the tiny particles of silica. So it's pretty clear there's been reaction between the warm water at the base of the ocean and the rocks. There's been a reaction called serpentinization, which is where you hydrate olivine and release some silica, and that is and produce some molecular hydrogen, H2, and that is a chemical process that life can piggyback on to use for its metabolism. So we've got everything happening inside Enceladus that you need to support life. So when I produce these moon trumps cards, I put potential for life in Europa 50% and Enceladus 30%. I might reverse that now.
Okay.
Because this was done before Cassini's. So was it Sam?
Yeah, it was
I
Sam.
don't think Enceladus deserves to be spoken of less than Europa. You know, they're both, the two of them share the honour of being the most interesting places for thinking about where life might exist, despite the damper that was put on Europa at the LPSC this year.
Yeah. So
they're both great bodies. Any more questions? No.
Well,
we can go back to the previous agenda then. There was a question asked yesterday in the Moons MOOC by Steve Bosley. This is one for you really, Sim. He's saying if the moon retains evidence of lots of bombardment, wouldn't that suggest that the composition of the moon's surface should vary quite significantly unless all those bombarding objects, asteroids and comets, had the same composition?
Okay, so thanks, Steve. I guess what you're talking about there is kind of variability across the surface of the moon. So we know that the moon's got variability, you know, from far side, near side, Mare regions, and highlands. So I think when you've got these impactors coming in, you have to realise that because here's where I reverse my story, because the moon's got no atmosphere, it's got a very thin atmosphere, but it doesn't significantly slow down those impactors. So these basically are very high energy processes. You've got these impacts going on, you know, really high speed. You get a lot of fragmentation, you get glass being formed in the heat of the collisions. So they're very, very energetic processes. So what that tends to do is kind of smear out this kind of perfect signature of an incoming body. So generally, what you can find is that there is that, you know, some kind of signal of the impactor that's come in. However, that can also be spread over large distances as well. The things that I'm particularly interested in, the volatile elements that are, you know, slightly different. So water that's coming in from asteroids and comets goes up into the atmosphere and then ends up kind of moving around, driven by day-night cycles, and ends up down at the lunar poles. So yes and no, I guess is the answer. You know, there is some heterogeneity there, and we need to understand that more for sure. A lot of this is hidden under this regolith layer, so the smashed up layer of soil that can be a few meters thick in places or tens of meters thick in the older regions. But getting down under that to understand what the actual the more native surface looks like are still questions that remain unanswered. So, yeah, more questions than answers, I'm afraid.
I'll give you another question before we go on to the news. Ben is asking, with plans for humans to return to the moon with commercial companies involved, will they be doing different things to what was done by the Apollo astronauts?
Yes, I think so. So the Apollo astronauts at first were intent on, you know, walking on the surface of the moon and getting back to Earth safely. We've got to remember that. You know, I still think it's a remarkable achievement. But as those missions progressed, there was increasing evidence, attention paid to science. And so, you know, eventually we had Jack Schmitt, who was not an astronaut, or not a fighter pilot, you know, test pilot, trained to be an astronaut. He was a geologist.
Yay.
Yeah, exactly. Could have been Dave. You know, he was a geologist trained to be an astronaut, and that was because there was this realization that you look at a planet in different eyes depending on, you know, your training. And certainly Jack Schmitt made some really important discoveries about which samples to bring back, for instance, because he spotted rocks which didn't belong where they were lying on the surface of the moon. So will the different things be going on? Yes, I think there'll be science happening that is kind of planned from the outset and built and designed into the mission from the start, as opposed to, you know, we've got to the moon now, what science can we do? I also think there's going to be some very practical work done. And this started with Apollo, you know, trying to take samples, trying to understand the radiation environment. But there is this overall idea now of trying to have a longer-term human presence on the moon. And if that's going to happen, there's going to be need to this infrastructure which we talked about earlier. So we're going to need to learn how to live on the moon. That's what my project's all about. Living on the moon is this kind of tagline we have to try and focus this idea that we're trying to do this for a long-term stay, not a touch and go, but maybe to spend extended periods on the surface of the moon. So we need shelter, which we can, you know, find caves to shelter from radiation, for instance. Maybe we can extract that water ice, which is at the poles, and use that for drinking water. Maybe we can split it into hydrogen and oxygen, and then we've got rocket fuel to fuel spacecraft or to generate energy. So I think there's going to be a real emphasis on these kind of practical technologies, demonstrating those technologies in situ using the ingenuity that you get in human hands, as opposed to robotic missions. So, you know, I think the future is going to be really interesting for what those astronauts can do.
Yeah, and so this is steps towards what's called in situ resource utilisation.
That's right. Yeah.
Living off the land or making rocket fuel to go further into space. There's no prospect, it makes no commercial sense to go to the moon, to take things from the moon to bring back to Earth to feed our military industrial complexes. The economics of it just don't stack up.
That's my belief, and I think that's a really important point to make, that the value of water on the moon is the fact it's on the moon. Yeah. And actually it's because you don't have to take it with you. So roughly speaking, these commercial missions would charge you about $1 million per kilogram of payload to the surface of the moon. So if you're going to create an astronaut community and a research base, yes, they'll have closed loop recirculation systems to, you know, to turn, you know, used water into drinking water. But they're never 100% efficient. You need to top those up. So if you can extract water from the surface of the moon and do that through a process that costs less than £1 million or $1 million per bottle, 1 litre bottle weighs a kilogram, then it becomes more efficient to use that water in situ than it does to bring it from Earth. But it's a circular argument. You need to have the community there creating a demand for it. And that's what NASA's tried to stimulate through its Commercial Lunar Payload Services program within Artemis.
Yeah. Thank you, Sim. Well, we've got no more live questions. Let's just go on to a bit more moons news, because there were a couple of papers last month in Icarus. Well, it's not really moons, it bears on moons. Stay with me, we'll get
there. Right, yep.
Observations with the James Webb Space Telescope.
Okay, yeah.
Eris and Makemake.
Okay, so there's a Kuiper Belt
They're
objects.
in the Kuiper Belt.
Yeah, okay.
They orbit further from the Sun than Pluto, but Pluto's a Kuiper Belt object as well. And we know their masses because they've each got moons of their own, so from that we can work out the mass. And Eris, although a little bit smaller than Pluto, has got a bit more mass than Pluto.
Okay.
So if it's a king of the Kuiper Belt, it's Eris, not Pluto. Makemake is a substantial body as well.
Pluto's had a tough time, hasn't it?
It doesn't mind. Pluto is an absolutely fascinating world. It might have an ocean inside it, but what we know from the James Webb Space Telescope observations is, or according to the authors of these papers, who are called, well, we've got their names. One's called Okay, William, it's Grundy the first one, and is it Glein the first author of the second paper? I think it is, yeah,
Yep.
Chris Glein.
Mhm.
So it's largely American teams here. They've used James Webb Space Telescope, and I didn't know you can do isotopic ratios with
Mhm.
mid-infrared spectroscopy from space.
Yeah.
And they have looked at the carbon-13 to carbon-12 ratio and the deuterium to hydrogen ratio in the methane in the ice on the surfaces of both Eris and Makemake. And they have said these isotopic ratios are wrong for ancient bodies in space formed of solar system material, and we think the only way to explain it is there's been water-rock interactions on the basis of internal oceans, and it
Wow,
must be quite
okay.
recent as well.
Mhm.
Now, believe them or not, but it is peer-reviewed papers suggesting oceans in the recent past in these Kuiper Belt objects, quite some way beyond Pluto. And what's kept them warm, we don't know, because
Yeah, they should be
it shouldn't be
cold
much tidal
places,
heating.
yeah.
They should be
Yeah.
pretty damn cold. But hey, internal oceans seem to be everywhere. There are more substantial sized moons in the solar system, Jupiter, Saturn, Uranus and Neptune, that now seem to have internal oceans than don't. Now, they may be dead on the floor if they're all like Europa where the faults can't penetrate, but we've got a picture of, this is the model from the paper.
Mhm.
So there's a sort of spectrum of activity there, and they're suggesting that early Makemake and even today's Eris might have heat sources in the rock and global water oceans. Makemake today might have moved a bit further to the right and be somewhat less active, but both places with feasible activity, maybe plumes venting to space like on Enceladus.
Yeah.
And other bodies that might, we think now, have internal oceans now or in the recent past include moons of Uranus. We've got a picture of Ariel somewhere, haven't we? This is Ariel. I was promised that would appear behind us when we're back on screen. There we go. Lovely,
Wow.
lovely
Wow.
moon with big cracks. That's quite an ancient surface because even the cracked areas have got impact craters on.
Yeah.
But moons of Uranus now with internal oceans as well. Everywhere you blooming look. Ceres, the dwarf planet in the asteroid belt, may have a relict internal ocean inside it as well. So we were disappointed when Venus turned out not to have an ocean and it was far too hot. But I don't regret the loss of Venus's ocean, given all the ones we've got in the outer solar system. The solar system is an amazing place. Any more live questions? Oh, another one from Sam. Okay, we'll deal with this, Sam. And then we should wind up. So this looks like it's one for you, Sim. If water on the moon is mined to support longer-term human settlements, how much water do you think would be available for human use?
Good question. Good question, Sam. That touches on lots of things. So that word mined, mining, it's a really good one. And the problem is on Earth that we associate mining with pollution, and it's necessary on Earth. Is it necessary on the moon? That's something that needs to be answered. One of the problems with mining for water on the moon is that the places where the water is most likely found, which is as ice at the polar regions, are not necessarily the places where you'd want to go and build lunar bases. So as a short-term top-up of water supplies for local bases, maybe that's feasible. And certainly, the lunar poles are rich in lunar ice. We think, you've got to remember that no one's actually gone down onto the surface and made those measurements, which is why we keep saying you need to have landed measurements.
We crashed a projectile into a permanently shadowed region.
We did.
Through a
We did.
plume of water.
L-Cross mission, and that gave the water ice concentration as 5% plus or minus 5%.
Okay.
I'm being a bit flippant, but through remote observations of a plume, to me that's not getting down on the surface and really making those measurements in situ. So I think those measurements need to be made, but I think it's likely that the poles will find that water. I think there's plenty of water there. Whether it's accessible economically probably is the question. We're not talking about supporting a massive population on the moon. We're talking about supporting research stations like you might have in Antarctica.
Yeah.
But interestingly, there's another way of getting water out of the moon, which is cooking moon rocks up with hydrogen gas, and hydrogen is implanted in the regolith from incoming solar wind.
And we have PhD students and postdocs working on this
right now. So they have. We build these ovens where we cook up the lunar soil for a few hours in the presence of some hydrogen gas, and we extract oxygen in the form of water from these rocks. So there is a process which will be tested in future, using a much more plentiful feedstock, if you like, just lunar soil, lunar rocks, which is available all over the surface of the moon. So although everyone talks about that kind of water ice on the moon as melt it and drink it, you need to purify it, by the way. Don't try it at home. It's got a lot of nasty stuff in there as well.
Don't drink the water.
Yeah. I think there are longer term, there are probably going to be other sources of water on the moon we need to tap into.
Good pun.
Sorry
Good
about
pun.
that. Yeah.
Moving swiftly on. We're going to wrap up now. Let's look at the widgets and see how people tackled the statistics of landing. How many nations have put astronauts on the moon? 100% of people who voted thought it was one nation. Well, that's correct, isn't it?
Yeah.
That's an easy question.
That's a good start.
Question. So that was NASA. 6 successful Apollo landings.
Yeah, I think that's
11
right.
through 17, but 13 didn't make it. Yeah. Okay.
Very good.
Next question. How many nations have soft-landed, uncrewed landers on the moon? The peak there is saying 5. I think that's right. So,
go on, you go first then.
Well, the Americans did it.
Yeah.
The Rangers and the Soviets
Soviet
did
Union.
it.
Yeah. Your turn again.
Oh, we're going to go from in order. Well, the next nation to land was China, surely.
Yeah. And then India.
Then India, yeah.
And then Slim.
And then Japanese.
Slim, yeah.
The Israelis tried, but they crashed with their beer sheet process. It's only 5 nations have landed on the moon.
I think,
most of you got that right. That was good. And how many nations have brought samples back from the moon?
That's an interesting one.
Oh dear, oh dear. Most of you think 1. Well, the Apollo program is the only way NASA's ever brought samples back, and they brought 320-ish kilograms back.
Of which more than half, I believe, is still untouched and is being analysed.
They opened some of the samples last
some new
year,
stuff
but
recently, but still giving science.
It's absolutely. The Russians in the mid to late 70s brought about 3 kilograms back. And more recently, sample returned by the Chinese from the near side, Mary Frigoris. They brought, I've got it written down here, they brought 1.7 kilos back, and they landed somewhere which, on the basis of counting craters, appeared to be a relatively young area of lunar mare. And it was dead right. Crater counting works. These samples came back. Radiometric data, more or less 2.0 billion years. The youngest lunar basalts ever sampled. So well done, China, for landing in the right place, carefully chosen for bringing stuff back. So 3 nations have brought samples back from the moon. NASA with astronauts picking them up, and 2 remote samplers.
So it shows there's different ways of achieving different, different outcomes.
Absolutely. And some of you need to swat up on your lunar sampling history. I thought there'd be more people that realised that China had brought the samples back. I thought that was quite famous recently. Anyway,
I guess so.
Interesting. So thank you so much for participating. Sim, thank you for coming along and sharing your vast depth of experience about what goes on with lunar programs. It's great to have you with me.
Pleasure.
Thank you, Ben and Kate in the background. There will be another Planets and Moons chat, I guess, in November for S283. If you, hopefully, those of you from 283 watching now won't be here with us again in November, but you'll be welcome to join us again in Planets and Moons chat. We'll make sure OU students know about it. So, good night, everybody.
I'll just do it like that.